I'm Juliette Graham. I'm an engineer at Motioneering. In the last chapter, we talked about bridges. Today, we're going to look at floor vibration. Floors can impact spaces in a number of different ways. If we have very large floor vibrations, they can make people uncomfortable, and in extreme cases, they can even cause panic. When we're looking at lower levels of vibration, they can impact sensitive processes such as surgeons working in operating rooms. They want to have vibrations that are lower than what they can perceive, so they're not causing a distraction. And then if we look at vibrations that are even smaller than that, vibrations that are much lower than what we can perceive can disrupt the performance of sensitive equipment such as MRIs. So if we're looking at adding damping to a system, we talk about adding tuned mass dampers to the system, which might sound like we're adding mass, but really we're looking at adding damping. And we're doing that in situations where we have these long span lightweight floors. So the floor is kind of responding like this. And then if we add a damper right to that point, then that can dramatically reduce that response. But then when we're talking about floors where we're putting sensitive equipment, those floors are already usually quite stiff and they're not responding just at a single point. So we can't start putting dampers everywhere where the floor is responding. So in those cases, we look at adding mass and stiffness to the system. And usually it's a combination of both of those things that we're adding. The use of the space does dictate the vibration criteria that we're targeting. In hospitals and research facilities where we're looking at those very low levels of vibration, the criteria is often very specific, and we know that we need to hit those targets in order for equipment to function properly. When we're looking at how vibration affects human comfort, the criteria can become more vague, and there's often room for conversations with the owners and architects about how they want the space to be perceived, how they expect the space to be used, and we determine the acceptable criteria from those conversations. We're not just concerned about vibration when we look at new builds. There's many cases where modifications to existing buildings can result in floor vibration issues that were not there previously. One example that comes to mind is in office buildings. We've seen the case where the office goes paperless and they remove paper filing systems from the floors. That decreases the weight on the floors a lot, and then the floor is able to move a lot more. So we might need mitigation because of that. Another example is that sometimes offices will go and put in a gym in the office space, and then they're holding aerobics classes in that gym, which can cause very high levels of floor vibration, which were not anticipated when the floor was originally designed. And then another example I can think of is we've worked on office buildings that have been converted to hospitals, and then they're going to put in an MRI, which is a very vibration sensitive piece of equipment, in a floor that was not designed for that. One example of a type of space that requires damping is a large open span ballroom. In that case, we might have a very large crowd of people that are all dancing along to a rhythmic beat. So they're not necessarily moving in perfect synchronization, but they are all moving at the same frequency. The structure is lightweight, and the people are likely to excite that structure at its resonant frequency. In that case, adding tuned mass dampers to the floor can have a significant impact on the floor's performance. Another example of when we might want to add damping to a structure, we're seeing this more and more recently, is that designers are creating these very unique spaces, and they often want them to have these long open spans to create a very open and a very specific aesthetic. If we were going to mitigate that by going in and adding columns or stiffening up the members, then that would really change the look that they were going for. So in that case, it's really helpful to be able to add tuned mass dampers to the floor to decrease the floor's vibration and still create the look that the designers had in mind. Another example where floor vibration can be an issue is where we're designing for very sensitive equipment, such as in hospitals and research facilities. I'm working on a project right now where sensitive equipment is being relocated from an existing old part of the hospital to a proposed new extension to the hospital. So we went in and did measurements on the existing floor to show the levels of vibration that we're currently working with the equipment, and then we're designing the new floor to achieve those same levels of vibration. If you've missed any of the chapters in our damping series, please check out our website at motioneering.ca. I'm Julia Graham, an engineer at Motioneering, and I look forward to speaking to you about your project.